In the last episode, we finished assembling this drone with the VELOX 70A SE ESC and VELOX F7 SE flight controller. In this video, I'll walk you through the basics of tuning it. First, plug in the USB cable, connect to Betaflight configurator and hit connect. Step 1. Go to the setup page and check if the gyro orientation is correct. As you can see, the flight controller sensors are all set correctly. Now, click Calibrate Accelerometer. Next, head to the Ports tab. I already enabled mine, but you just need to turn on the ports for each peripheral you connected. For example, my UART2 is connected directly to the DJI-03 air unit. So under Peripherals, I select VTS MSB plus DisplayPort. If you're using analog video, you'd usually pick IRC Tramp or TBS Smart Audio. The exact choice depends on the VTX protocol you use. So I enable serial-based receiver there. On the VELOX F7 SE, UART 6 is usually reserved for Bluetooth. That way, once powered, you can tune from your phone without plugging in a cable. UART 5 is for GPS in my setup. So under Sensor Input for UART 5, I select GPS. Once all peripherals are set, move on to the configuration page. Here, if your gyro orientation is flipped, you'll need to manually rotate the gyro orientation by 180. Adjust the numbers here according to your actual setup. Next, under arming, the default maximum arm angle is 25. I change it to 180, so even upside down, we can still use turtle mode. At the bottom, enable functions like air mode and GPS. Now, let's go to the presets page. If you're using HD video like DJI-03, search DJI-03 under presets. That's the one. Make sure to tick the port you connected the VTX to, which was UART2 for me. Then hit save and reboot. That way, the OST will be ready on your VTX. Reconnect once it restarts. Next, head to the PID Tuning tab. If you're not familiar with your drone's condition, I suggest sticking with default PIDs first. But since my build is solid, I can push it straight away. I'll raise the master multiplier up to about 1.15. I'll lower the I-term slightly on a 5-inch freestyle quad without a GoPro. I keep it conservative. For D-gain, I keep it close to P, around 6. For feed forward, since this build is light, I set it around 1:0.130. Then increase D-max a bit. Feed forward. On the right, for feed forward smoothing, I'm using an Ehlers receiver with my radio running at 500 Hz. So I raised the smoothing to prevent motor noise when arming. For TPA, since this is a high-speed build, I want more PD at full throttle, so I lower the TPA rate to about 50%. TPA breakpoint stays at 1350, which is fine. Click Save. But keep in mind this setup uses a BME for the 688 gyro, and not every quad will work well with these settings. It's most important to tune according to your own build's condition. My FC has no wires above it and is mounted flat, so these numbers work fine. If your build isn't as clean, start from defaults. Raise them slowly to test the limits. That's the safest way. Now let's move on to the filter settings. For filters, I pulled the low pass to 1.1. For safety, I enabled 3 RPM filters. The minimum frequency starts at 100. I also enabled dynamic notch with 3 slots. Set the min frequency to 110 and max to 500. On this photon frame, resonance is usually around 220 Hz, just a single peak. But for safety, I still keep 3 notches. Turn off the gyro notch and yaw low pass filters. For D-term filtering, I'll keep these settings or push it slightly higher. Switch to manual input and set the D-term minimum cutoff at 100. Filters, like PIDs, depend on your build. You need to test step by step. Don't max it out immediately like I did. Start with defaults, test, then increase slowly if it flies fine. For modes, I added arm, angle mode, beeper, flip over after crash turtle mode, and also GPS rescue. Set the channel switches according to your radio. Now let's move to the GPS tab. I'm using a BZ181 GPS, so I set protocol to UPLOX. Enable Galileo, set home point on ARM, and other options. For assisted type, select Auto Detect. Save and reboot. Now adjust the failsafe tab. I mapped GPS rescue to aux3, so I set it to SET and drag it to the bottom. That's a channel value of 1800, which enables it. Change the failsafe stage to action to GPS rescue. Minimum sets is 8 by default, keep it at least that. I recommend enabling rescue only after 8+ satellites are locked. This ensures accurate return to home. Enable the option allowing arming even without enough satellites. Enable the option allowing arming even without enough satellites. My hover throttle is around 1430, so I set it there. That's the hover point. Save and reboot. Now go to the Motors tab. Let's calibrate motor order and direction. Power up the quad, hit reorder motors, spin them, then save. Next, fix motor direction. My motors 1 and 4 are reversed. Just flip them in Blayley configurator. Done. Now head to the OST tab to arrange your OST info. I already customized mine. The key thing is the video format. If you're on Hadro, DJI-O3, etc. Select HD. If you're on analog, pick NTSC or PAL depending on your camera. Since I have GPS, I added speed data, also added ESC RPM, per cell voltage, and total voltage, plus current draw, throttle, ARCS link quality, and flight time. Once arranged, hit save. In the VTX tab, for HD systems, you don't need to change anything. For analog VTX, import the correct VTX table, then pick band, channel, and power level. Lastly, in the black box tab, enable logging. Set log rate to 1 kHz, debug mode to gyro scaled. Save and reboot. Before enabling, erase the flash memory. That completes the flight controller setup. Next, disconnect Betaflight and open M32 configurator. The VELOX 70A SE is an M32 ESC, so power it up. Pick the port, connect, and read settings. My ESC firmware is version 2.17. I recommend updating to the latest version. For settings, I raise motor timing to max, 22.5. Startup power I set lower, around 90%. The key setting here is motor KV. Set it about 50-60 higher than your motor's rated KV. My motor is F80 Pro 1900 kV, so I set it to 2100. PWM refresh rate, I set to 2448 kHz dynamic range. Once everything looks good, click Save. Okay, ESC tuning is done. Now the quad is ready for a test flight. That wraps up this tuning guide. See you next time.